Hi everyone, today we're going to be looking at quadratic modelling, so some application style questions using your CAS to your advantage. Now when it comes to using your CAS for quadratic modelling, you want to use things like your graph function, your trace and your solve functions, as well as the analysis function on the calculator for those intersection points, okay? Now, looking at this example here, this is one where you can answer a couple of questions by hand if you really like, but we can also just graph it and work from there. So I'm going to open up the graph on my CAS, remembering that we use X instead of T in this scenario, but then just putting T in your answers for things like your time and your height, etc. So I'm going to expand when I pop this into the calculator. I'm going to have 30x, take away x to the power of 2. And I am going to restrict my domain a little bit as well, just so that when I look at my graph, I don't accidentally go beyond the domain. So remembering that's our given that sign, and we're going to work between 0 and 30 because of what this question is asking. Now, once you've done that, hopefully when we go window fit, it should fit in most of your graph with a restricted domain. And then we're just going to zoom out a little bit as well. So that's what our graph looks like, and I'm going to delete that label as well because I don't particularly feel that I need it. Now, if I would like to sketch this graph between 0 and 30, we can see that we've got a very nice even parabola here. So I'm just going to sketch this like I normally would, remembering we don't actually have to be perfect when we are just sketching and we haven't been given a scale, okay? So we've got 0, 0 here, and then another really key point to label on any parabola is our turning point. You can find this in two ways. We can trace the graph, or we can just try and find our maximum because we can see that's a max point here. So our turning point for this one happens at 15 to 25, okay? Now, if we want to see for this first example how long it will take for the rocket to reach its maximum height, well, we found that that maximum happens at 15, remembering that this axis here is t in seconds, and this axis here being height in meters. So we know it's going to take 15 seconds for our rocket to reach its maximum height. Now, what the maximum height is that's being reached by the rocket is that 225, so 225 meters is its maximum height. Now, if we want to find out how long it's going to take for our rocket to reach 150 meters, well, I'm going to plug 150 into my calculator and then look for that intersection point between the two. Now, we want to know how long it'll take the first time because it's asking how long will it take to reach that point. Okay, so I'm going to go analyze, intersection, and then go for that first intersection point there. Now, we only want one decimal place, so we can see it's 6.3, 150. So it will be after 6.3 seconds that we will reach that height of 100 meters. Now, the last question here is just asking why our domain has to be between 0 and 30. That's something to just think about a little bit logically here. So we've got the height of a rocket that's being measured and the time it takes. You cannot have a negative time when it comes to things like this. And you also can't have a negative height, right? We're assuming that this is ground level is our x-axis and we cannot have a negative height. So the reason that our domain has to be between 0 and 30 is because we cannot have a negative time or a negative height either, okay? So it really is just a bit of a logical question there. So you have to be careful in application questions, making sure that you're within a reasonable domain. And this is called an implied domain for these sorts of questions, okay? Now, feel free to pause here and give this one a go by yourself, that I will also definitely go through it. Now, for a question like this where you're working with length and width, you've got two variables here to work with, but we only want to use one variable like x or y, okay? So in this case, we need to figure out how we're going to represent the width and how we're going to represent the length, okay? Now, we've been told that our width is x, but we haven't been told what our length is, and we have to write out our length in regards to x. Now we've been told that for this fence, we have 60 meters of fencing just to construct the 3 sides. So we don't have to worry about that 4th side there. Okay, so I want to figure out what I'm going to call this length here. Now, if we've already got the 2 x's from the width, okay, and we originally started off with 60 meters of fencing, our length is going to end up being 60 meters take away 2 widths, okay? So our length is 60 take 2x, which means that our area in this case is 60 take 2x times x. Okay, so we can also write this out at 60x minus 2x squared. So we've got another upside down parabola here. Now we want to know a possible domain for this rule. Really keep in mind that for something like area and length that it has to be positive. And we also want to know why the endpoints are not included. Okay, so it's another one of a logical question. Now our implied domain for this question here is that x is greater than 0 and that our highest x value is just below 30. Okay, so we can't have 30. Now, we cannot have the endpoints included in this question because we would get a side dimension of 0. Okay, and if the endpoints were included, so if 0 or 30 are included, then our area ends up being 0, right? And we can't have an area of 0 meters squared like this because then you've actually just got one long fence instead of a rectangle, okay? So the endpoints are not included because that would actually get rid of our rectangle and it would just be one long fence, okay? Now, we've been told that we have to include, well, we have to think about this domain going forward for this function. So now that you know that your function's working between 0 and 30, considering we already had that for this one here, I can just kind of change my function here a little bit. And I'm going to make this 60, and I'm going to make this 2x squared between 0 and 30, and then I'm just going to get rid of that red line there. We don't need that anymore. What you could see there is that all that did was stretch my graph upwards because we've got that new dilation factor. So we've dilated a factor of 2 away from the x-axis. Now we want to give this a nice sketch. Because you've been given a scale, we want to make this look as nice as possible. Remember that in this case, your endpoints are not included, so they need to be open circles for both those endpoints. And then we want to try and make this as accurate as possible with our turning point there. To get your turning point, once again, we're going to analyse and go for our maximum and get our turning point there, which is 15,450. So that means my graph's going to be nice and relatively even when I sketch it, remembering that those 2 endpoints have to be open circles, okay? Now we've already found that our maximum area is 450 meters squared, that our width, because that's x, is 15 meters, and then our length is going to be 60 minus 2 times 15, which is 30 meters. So to maximize the area on this yard, we're going to have a width of 15 meters and a length of 30 meters.